Most people hear math. They think about long calculations involving large numbers, never-ending fractions, and logarithms everywhere. But the question I'm thinking about is, how do we study the universe? This might not seem like a math problem at first glance. After all, we have telescopes that astronomers use to form pictures of our visible corner of the cosmos. But there's no telescope that can see the whole universe at once. What does space as a whole look like? Does it look like this? Or like this? Or maybe it looks something like this. At the end of the day, this is a geometry problem. Or put differently, how many holes does the universe have? And if we can't count these holes with our eyes or with a telescope, is there some other way to detect them? Using math, we can hear the shape of an object without ever seeing it. Take this donut again, for instance. The bottom and the top of the hole are special regions called saddles. At the bottom of the hole, there's a curve that swings down. There's also a curve that swings up, just like a riding saddle. The saddles are very special in geometry. They're like musical notes that can be heard amongst the noise of the rest of the shape. To help hear these notes, we need equations, and one of the best gifts that Einstein gave the world was an equation. Not E equal to mc squared, but this one. This is his famous field equation, which describes the shape of the universe. It's part of the general theory of relativity, whose predictions have been verified experimentally over the past 100 years in many different ways. The question is, can we hear those special notes, the song of the saddles, if you will, inside Einstein's equations, or within other newer equations in physics, such as those coming to us by way of string theory? Math has the power to answer these questions, and the whole universe is our lab.